All right, this is a nice bell work, write an equivalent fraction to 1/2 has a denominator of 20. So I'm just going to write out 1/2 right here like this. And we want a new fraction, but the denominator is 20, so that's the bottom number in the fraction. We just got to figure out what this missing value is. Now these are equivalent, which indicates that they are equal to each other. So they have exactly the same value, they're just shown in different ways. Now remember, this is a scaling of fractions because we're changing the way it looks, which means we have to use either multiplication or division. So from here I can see that I'd have to go from 2 to 20 because we're going from 1 to the unknown value here. So what would I have to do to 2 to make it a 20? Well, I'd have to multiply it by 10. So 2 times 10 would give me 20. And then in the numerator, I'd have to multiply it by the same factor of 10. And 1 times 10 gives me the new numerator of, well, 10. So these two fractions, 1 over 2 and also 10 over 20, have exactly the same value. They're just shown differently with a new denominator of 20. And this is a skill we're going to need to possess in order to do well on our quizzes and tests. So, but like we've seen on the homework, of course, it would only want the numerator there, 10. But we should be able to do this with choosing our own denominator as well, whether it was like a 4 or a 6 or something like that. All right, there's our objective for the day. I can write fractions in their decimal format, and I can write decimals in their fraction format without changing the value. This goes into the idea that we can change the way numbers look, but it will not change their actual value overall. So just like what we saw in the bell work, we can change the way it looks, not changing the value. Take a minute and copy this down, please. All right. One of the challenges we run into is we see students struggle to write a number like this as a decimal. But remember, from, I think it was 2.1, where you have a decimal like this, you have like the ones, the tens, and the hundreds. And then to the right of the decimal, you have tenths, hundredths, and thousandths, and so forth. This number right here is just, it's not really showing any decimals or decimal place values, but they're there. So you could write 10, for example, as 10. Now remember, this kind of would fill out the tens and the ones place value. And so there is a decimal to the right of the 0 in the ones place value. It's just you don't usually see it. So you could say, well, I'm just going to write this as 10 point. You could say 10.0. You could tack on 2 zeros or 3 or 4. Really, you could tack on as many of these as you want. So I put three dots right here just to indicate that these zeros, they're going to go on like this forever and ever, if you need to. Technically speaking, we don't usually need more than, I guess, like 2 decimal place values like this. We may see a need for more on the homework, but at least on the lesson, probably not more than this. And there is a need for writing actual whole values as decimals in mathematics. So we'll see one of those applications today. On the other hand, we need to be able to write fractions as, and mixed numbers also as decimals. That's kind of part of our objective for the day. So if you see that you have a mixed number, whatever the whole value is, you just keep it there, okay? So if you see a mixed number like, I don't know, we'll say 8 and 5/7, something like this, okay? Automatically, just on this first step right here, you'd make it 8 point something because of the 8 whole value right there like that, okay? And then after that, you'd do 5 divided by 7 with long division. That's kind of our second step. Showing any phantom zeros to expand the numbers if you need to, just like we saw with 10, right? If you needed to show 10 with some phantom zeros, right here, they were there the whole time, just since we didn't need them, we didn't actually show them. But now with long division, we may need these zeros, okay? Recall also that the numerator is the dividend in a long division problem. So it goes inside the actual long division sign like this. Okay, so the 5/7, you'd have the 5 here inside the long division, and then the 7 would be on the outside because it's the divisor or the denominator, okay? And we'll show more on this later. But this is the process. So 3/5, can we change this into a decimal? Yeah, sure. And again, this is long division. Some of you may benefit from writing this first as an actual division problem like this, 3 divided by 5. Now that doesn't it doesn't help us too much in terms of long division, okay, or changing this into a decimal. Although again, just visually may help you to understand and remember that the fraction line is a division sign. So I'm going to use long division on this case. So 3 divided by 5. Now usually when we're getting used to this, some students say, why'd you make this long division line so long? And actually that's a pretty straight line for me, so I feel proud of this one. But the reason is because 5 won't go into 3. Right off the bat, 5 won't go into 3, which means that I will need to make this 3 a 3.0 to start out with. Now I put the decimal there, and this is the beauty of our number system and kind of our strategies for operating with them. The decimal with long division, since we're lining everything by place values, the decimal stays in that spot as well. So now that as I solve for my quotient here, the decimal place is already in the problem, okay? Then I say, hey, look, I look at 5, I don't look at this as 3.0. I now look at it as just 30. How many times does 5 go into 30? That's 6 times. Then I'd say, well, 6 times 5 is 30, lining up the place values. And when I subtract these, I see that it kind of zeroes out right there, just like we wanted to. So perhaps I made these even longer than I needed to. And that also means then that 0.6 is the actual quotient, which means it's the same as 3/5, just in its decimal format, okay? So why change fractions into decimals? Because some people prefer to work with decimals instead of fractions. Some people may choose to work with fractions instead of decimals. It really is up to you, although in my experience, fractions have destroyed more lives, but you can decide for yourself, all right? So there we go. And another thing to keep in mind is on the homework, it will accept not only 0.6, but some of you like to just write 0.6 like this. If you're doing this by hand, my only point here is just to make sure that this decimal is noticeable, because sometimes students will they'll write it so small like this right here. I know you can't probably see that, but I did put one in there. So if that is you and you have to write these really small, just kind of emphasize that decimal right there, okay? So that we know that there is an actual decimal. All right, let's do this one then. 5 over 6, which again is really 5 divided by 6. So as a long division problem, this is 5 divided by 6. Okay, and right off the bat, once again, I see that 5 is too small for 6. So I know that 6 will go into 5 exactly 0 times. I mean, almost 1 time, but 0 times. So remember the decimal. So there's my decimal. I do need to bring that up into my quotient there, though, so that it's all lined up. Okay. Now, why would I do that? Because I can expand the 5 and just make it 50 right here, like this. Okay. Now again, I'm looking at this like 50 instead of 5 or 5.0. And it's kind of like saying, well, we got 50 tenths is really how that comes out. 6 will go into the 50 there 8 times. And so we see the need for remembering, hopefully memorizing our multiplication tables up to at least 12. 8 times 6 is 48 there. So when I subtract here, I get 2, okay? Now, the 2 here that I just got remaining, it's too small for the 6, but if I tack on another 0 into now the 100th place value and drop it to make this 20, yeah, I can make it big enough. So you see how we can kind of force the numbers to be what we want to be in order to expand these values. 6 will go into 20 3 times. 3 times 6 is 18. So when I subtract this, 20 minus 18 is 2. But again, I can tack on another 0 to my 5 and make this now 20 again. 6 will go into 20. Yep, 3 times. And yes, there's a pattern emerging here. We'll keep showing it though. 3 times 6 is 18. When I subtract this, 20 minus 18 is 2. Tack on another 0 and drop it to make this 20. Yeah, 6 will go into 23 times. Now, you could continue this as far as you need to go, but you'll see this pattern emerges. There's 20, 20, 20. And it's just going to be 20 from here on out. And so these 3's actually are just going to repeat. Okay. Now, we have a way to express that, like I'm doing with the 3 dots here. This problem, though, wanted us to round specifically to the thousandths. So I probably Yeah, this is the 10,000ths right there, so that's good enough. So remember, this is where it would say, look, you underline the place value you're targeting, which in this case is the thousandths. That's 3 place values, by the way. That's important because the homework will want 3 place values. And then we circle the number to the right. This 3 in orange in the 10,000ths, is it 5 or more? No, it is not. So this would just round into, I'm going to write 0.833. That is the thousandths place value. And this is what we would want entered on the homework as well. All right, when we see a number, a decimal number that repeats, we end up using what we call bar notation. So on that last example where it was 0.8333, I think we got one more 3, and this just repeats, right? We actually use formally what we would call bar notation in mathematics, where we'd say the 3, look, this 3 is just going to repeat. Now, since there was 3's to the left, you could put a bar over those. If you wanted to change this into formal mathematics, you would only have the 1, 3 here. That would be considered fully simplified at that point, okay? Now, sometimes you may see that 2 numbers may repeat, such as, it doesn't really matter what you get, but something like this, okay? If 2 numbers repeat, then you put a bar over both numbers. It is possible to have 3 numbers repeat like this. And you see on the example that we just did where the 8 did not repeat, so notice the bar is not over the 8 because it by itself is not repeating. You only put a bar over the numbers that do repeat. Now, again, this is a formal way to show that numbers repeat. But remember on the homework, it will tell you to round because Canvas doesn't have a good way for you to put bar notation in, okay? All right, yeah, so as soon as you see with long division that there's numbers that repeat, pretty much the moment you see it, you can start putting a bar over the number that repeats, or the numbers that repeat. But if it takes a little bit longer, like we did on that last problem, to see that there is a pattern that repeats, then so be it. Okay, as long as you understand that it will repeat forever and ever and ever, that's the important part. All right, what about changing a mixed number into a decimal? Well, a mixed number is pretty much the same, but remember with our steps there, is that this -5 whole number is going to stay as part of our decimal. It's just -5 point something. And the decimal is what we will get from the 1/3 here. So this allows me to ignore the whole number here, the -5, which then allows me to just look at only 1/3, which is the same as 1 divided by 3. So with some long division, 1 divided by 3, well, 3 won't go into 1, so there's 0, and it should be 0 because we got a 5 already in the ones place value. So there's my decimal. I line up my decimals. I make this now 10. 3 will go into 10. Yeah, 3 times 3 is 9. Now when I subtract here, I get a 1. Now some of you notice that the ones have already started to repeat. I can just emphasize this by adding more zeros though. So I'll make that another 0, 1.00. There's another, see, 10 and 10 again, just in case you needed it. 3 goes into 10, 3 times 3 is 9. When I subtract, boom, another 1. Now again, you could continue this if you'd like. You can show this 3 repeats or both 3's. Doesn't really matter to me. Although technically speaking, once again, mathematically, they would only want 1 3, and that would be considered simplified. Now, notice here I tacked it onto my -5 there, which is really what we need to remember to do because sometimes I forget that just to add the decimal onto the whole part of the decimal there, okay? Now, keep in mind, if on the homework you end up changing decimals into mixed numbers, the homework will want you to write those as improper fractions, okay? And while we may not see an example today of changing an improper fraction into a decimal, that's just long division, just regular long division there, okay? It's just you may have to tack on a decimal and some zeros onto your number in order to make that work. Converting decimals to fractions. Now, as we've seen before with decimal place values, see if I can make this work. There we go. So remember, if you got the decimal right in the middle, you have ones, tens, hundreds, and so forth to the left of the decimal, okay? If you have any numbers in these place values, that is already automatically the whole number in the mixed number, okay? If you have a 0 in the ones place value and nothing else in the tens or hundreds and so forth, then it's automatically a proper fraction. You wouldn't need the mixed number format, okay? So if by chance you see a 0 here and there's no other place values there to the left, you would not write this as 0 with some fraction, okay? Do not do that. We would just write it as a proper fraction, okay? So if you see numbers to the left of the decimal, those are the whole value part of the mixed number. Then anything to the right of the decimal, we write as part of the fraction, but that's a numerator, pretty much ignoring any of the place values, okay? Then you look to the number that's furthest to the right in the decimal. Its place value is the denominator. Not the number, its place value is the denominator, okay? And then you look at the fraction part of whatever, if it's a mixed number or a proper fraction, you would look to simplify those. And then again, keep in mind if you get a mixed number, on the homework it's going to want you to change those into improper fractions, okay? So that may not make a lot of sense right now, but hopefully after an example it will. So 0.366. Now again, this is a 0 there in the ones place value. So once again, I will not write this as 0 with some fraction. No, we don't want to see the 0 there. We want just the fraction part of this. Since it's a 0 in the ones place value, it will just simply be a proper fraction, okay? And then I look at the decimal part of the number, and I would look at that as just 36, okay? And then I would write that in the numerator as just 36. No decimals, no nothing right there, just the 36. And then I look to the place value furthest to the right here, the 6. That is in the hundredths place value. So the hundredths is the denominator, hundredths. And just so you understand, while we didn't really look at this in too much detail, this reads 36 hundredths technically, and this also reads 36 hundredths. So if you can read this out loud instead of 0.36 but 36 hundredths, it will give you the fractional part of it, okay? Well, last thing we should do now that we have the fraction is to see if this can be simplified. And I know that 36 and 100 are both not only divisible by 2, but 4, okay? Because I know 100 can be split into quarters, that would be fourths. Now the numerator, I know 36 divided by 4 is 9. Now if you're not familiar with 100 divided by 4, you may have to use some long division like this, which is okay. And again, I'm doing this with one scaling down, but you may have to scale it down twice if you didn't notice that both are divisible by 4. So I'd say 4, it will not go into 1, but it will go into 10 twice. 2 times 4 is 8. So when I subtract 10 minus 8 is 2. See, then I drop a 0. 4 goes into 25 times, and then 5 times 4 is 20. That zeroes out. And my quotient there, 25, is the denominator. Now what I have here is 9 over 25. Remember, when you're scaling fractions with division or multiplication, you have to be able to divide or multiply by the same thing in both the numerator and denominator. So if by chance I couldn't find anything that both were divisible by, it would be done. Like 9/25. So I know 9 is divisible by 9 and 3, but 25 is not, so automatically this would be finished. If you'd prefer to look at the 25, 25 is divisible by 25 and 5, but 9 is not. So they're not divisible by any of the same values, which means that 9 over 25 is our final answer. It is fully simplified. Now, something else you should notice is that we wrote 0.36 in 3 different ways, but they all have the same value. That's the key point. Sometimes you may need 36 hundredths. Sometimes you may need 9/25ths. It depends on the scenario we're looking at. Right now, for the homework, it will want just the simplified fraction. Now, let's try this one. Right, this decimal is a mixed number. Why? How do we know this is a mixed number? Because it has a value in the ones place value, right? Not a 0, which means automatically this is going to be 5 and something. Okay, so this is where I take just the decimal part, 0.8, maybe 0.8, depending on what you like. And again, the 8, I just write that as my numerator for the fraction. And then what is the place value of the 8? That is in the tenths place value, which makes that 8/10, like this. But again, can that fraction be simplified? This is my fractional part of my mixed number. Yeah, sure it can. These are both divisible by 2. which now makes this fraction 8 divided by 2 is 4, and 10 divided by 2 is 5, 4/5. Again, just check, always make sure to see that this is fully simplified. 4/5, 4 is only divisible by 4 and 2, 5 is not divisible by either of those, so that would be my final fraction, 5 and 4/5. Now, if you're doing this by hand, remember not to write this as 5 and 4/5, like this, because it looks like 54/5, okay? Notice the way that I have this written, the whole number is deliberately larger than the numbers in the fraction, and then the fraction line, I've even tried to split that pretty well in half. So and then the fraction numbers are smaller, okay? Don't do this stuff here on the right because it may lose you points if you have to write stuff by hand in the future. That's it. Yeah, and yeah, just real quick too, since Canvas will not accept the mixed numbers, we will have to change this into an improper fraction, right? Remember, that won't change the denominator, so I got my denominator 5 there, this 5 in green, and then we use cycle method to change that, right? So that'd be 5 times 5, which is 25, and then you add the numerator 4 to get 29. So the final answer on this one really, at least for Canvas, would be the 29/5. So there's your decimal, there's your mixed number, there's your improper fraction. These all have the same value, they're just shown different ways. But again, Canvas would want the 29/5. 0.675, that would read 675 thousandths, but change this into a fraction in lowest terms. 1 minute, go. So 0.675, and again, since the 0 is in the ones place value, this is going to be a proper fraction, all right? So the first thing I would do is write this out as though there were no decimal, meaning that I would read that as 675. That's my numerator, 675. The place value of the 5, the number furthest to the right, is in the thousandths place value. And that will be my denominator, thousandths, like this, okay? Now, if that could not be simplified, it would be done, but I see if the 5 and the 0 in the ones place value, which means that both of these, right off the bat here, are divisible by 5. So let's go ahead and get that done. Divide this by 5 and divide this one by 5, okay? And yeah, I think some of you recognize that these are both divisible by 25, but I'm going to skip that because I don't think everyone will notice that, okay? So we're going to have to take 675 and divide it by 5. So 5 will go into 6 once. 1 times 5 is 5. When I subtract, I get 1. Drop to 7. 5 goes into 17 then 3 times. 3 times 5 is 15. When I subtract, I get a 2. Drop to 5, making that 25. 5 goes into 25 5 times. So that would give me 0 remaining on that, which means that my new numerator, after simplification, is 135. But then I'd have to do the same thing with 1,000 divided by 5. And again, I think some of you would know that pretty quick, but just in case you didn't, 1,000 divided by 5. 5 won't go into 1, but it will go into 10 2 times. 2 times 5 is 10. So that will zero that out. What about the tens place value? No, 5 won't go into 0. Will go into 2 zeros. No. So that's 200, my quotient. So I end up right now with 135 over 200. But even though we've done a simplification, we should always ask, can this be further simplified? And the answer to this one is yes. Again, with the 5 and the 0 and the ones place value, that means that these two are both still divisible by 5. Okay, so what are we going to get from that? Well, let's do some long division. So we'll start with 135 divided by 5. 5 goes into 1, nope. But 13, yes, 2 times. 2 times 5 is 10. When I subtract, 13 minus 10 is 3. Drop the 5, 35. 5 goes into 35 7 times. So that's my new numerator, 27. And then my new denominator, 200 divided by 5. So 5 won't go into 2, but it will go into 20 4 times. 4 times 5 is 20. That zeroes that out. What about the 0 and the 1s? No, 5 won't go into that either. So 200 divided by 5 is 40. So again, we got a new fraction. Can this be simplified? 27 is divisible by 27, 3, and 9. 40 is not divisible by any of those. 40 is divisible by 40, 20, 10, 4, and 2. and 5 and 8. There we go. But yeah, 27 is not divisible by any of those, which means that that is a fully simplified fraction. All right, let's write this decimal as a mixed number. How do we know it's a mixed number? Because of the 7 in the ones place value. So again, right off the bat, I'll write this as a mixed number, 7 and something. Okay, so I just need to fill in my blanks for the fraction, but the 7 I know right away. So then I look at this as just 0.12, which as a fraction would be, again, that'd be 12 as my numerator, and then the 2 in furthest to the right there is in the hundredths place value. So it's 12 over 100. I see again that 12, I know it's divisible by 4. You could say 2, but I'm going to go further and say 4. These both are divisible by 4. 12 divided by 4 is 3, and 100 divided by 4 is 25. I think we've done that already. So it ends up being 3 over 25. Can this be simplified? Well, 3 is already prime, and 25 is not divisible by 3, so that's done. Well, we just got to put it in with the mixed number, right? 7 and a 3 25ths. Yeah, now that's done. All right, there's our objective again. I can write fractions in their decimal format, but also we should be able to write decimals in their fraction format, simplified by the way. And again, that it won't change the value. It only changes the way that the fraction or decimal looks.